So this is the lesson on special cases of systems. So let's put this brief thing in your notebook. So we've been solving systems for several class periods now, and all of the problems that we've actually done and found solutions to were the case where if you graphed the two lines, they would intersect in one point. So this is what we've been doing, and the solution would be the point of intersection. There are two other cases that we did talk about, but just to remind you, if you graphed your two lines and it turned out that they happened to be parallel, notice parallel lines never intersect. So solutions would be points that are true for both equations. Since these don't intersect, there are no solutions. Now, a different case would be if you graphed one of your lines and your other line, it might be in a different form, so you didn't recognize it. But when you graphed it, it landed right on top and it turned out that it was the same line. So if you have two lines that happen to be the same line, they intersect everywhere along that line. So many, 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 many points. So that turns out to be infinitely many solutions. Now, make sure you notice that infinitely many doesn't mean infinity. If you say the answer is infinity, that means it's one value that's really, really big. But these are XY pairs, and there are many, many of them, but not every single point in space. I could pick a point over here that was not a solution to this. Now, what does this look like if we're doing the algebra to solve? So if you end up with something that looks like, so you do all the work to solve it, and you get something that is not true. For example, if you do all the work and you get something like 4 equals 7, clearly 4 does not equal 7. That means there is no solution to that system. Similarly, if you did all the work to solve algebraically and you got something that's always true, for example, if you got something like 4 equals 4, 4 is always equal to 4. That would mean there are infinitely many solutions. So now we're going to do some examples. So take out or print the worksheet that I attached that says systems of equations special cases. So we're going to do number 1 from your worksheet, and I'm going to do it on a piece of paper. So our first problem, number 1, from your worksheet, has the system 3x plus 5y equals 1 and negative 6x minus 10y equals 14. So I'm going to use elimination. So I look at 3 and negative 6, and I think if I multiply this equation by 2, I'm going to get a 6 here and a negative 6 in front of that x, and when I add, they'll add up to 0. So I'm going to multiply, so 2 times 3x is 6x, 2 times 5y is 10y, 2 times 1 is 2, and I'm going to copy this equation underneath the first one. Now if I add, 6x plus 6y is eliminated as I planned. Negative 10y minus 10y, that turns out to be 0 as well. And 2 plus 14 is 16. Whoa, this is funny. No x's and y's. 0 equals 16. That is absolutely not true. So that means that there is no solution to this system. That's the answer. I'm done. But just so you're aware, remember, no solution happens when the lines are parallel. Right, and my next example, I'm going to do number 3 from the same worksheet. So that is this problem from the worksheet right here, number 3. So I have 7x plus 3y equals 0 and 14x plus 6y equals 0. So I look at 7 and 14, and I think they have a common multiple of 14. So if I multiply this by 2, I get 14. Is that what I want? 14 plus 14 is 28, not quite. So I'm going to multiply by -2, and that will give me a -14 and a +14. So if I write that over here, -2 times 7 is -14x. -2 times 3 is -6y. -2 times 0 is 0. I'm going to copy the bottom equation. And I'm going to add 14x plus 14x is eliminated just like I planned. -6y plus 6y. Oh, that adds up to 0 as well. And 0 plus 0 is 0. Interesting. 0 equals 0. 0 always equals 0. That is always true. So remember, when we get something that's always true, that means there are infinitely many solutions. So that's the answer, infinitely many solutions. But remember, that happens when they are the same line. That's not the answer, but just so you know, they're the same line. And that is the end of this lesson.